Okay, let us proceed now for the linear coefficients in two variables. Now, the section aims to discuss the transformation in the method involved in the linear coefficient in two variables and solve differential equation involving linear coefficients in two variables. Now, consider the linear equations a sub 1x plus b sub 1y plus C1 is equal to 0. This one is for equation 1. Then we have a sub 2x plus b sub 2y plus C2 is equal to 0. This one is equation number 2. Notice that the graph, this equation are straight lines. Substituting the left-hand number of equation 1 in m and that of equation 2 in n of a differential equation, we have m dx plus n dy equal to 0 gives a sub 1x plus b sub 1y plus c1 dx plus a2x plus b2y plus c2 dy is equal to 0. Now, this is called the differential equation with linear coefficients in two linear variables. Now, if the two linear equations representing two straight lines intersect, then let h and k be the point of intersection. Then, we have to define a transformation of the differential equation for x and y as follow. We have x is equal to u plus h. Okay, in getting the derivative of this one, we have dx is equal to du. Remember, h here is a constant while u is a variable. Then we have y is equal to v plus k. Okay, where v is a variable, k is a constant. Therefore, in getting for the derivative, we have dy is equal to db. Now, substituting this equation in differential equation give the following. We have a1 times u plus h. We substitute your x into u plus h. Plus b1, we have v plus k plus c1 dx plus a2, we have u plus h plus b2 v plus k plus c2 dy is equal to 0. Then, simplifying, we have a1u plus b1v plus a1h plus b1k plus c1, plus c1 du plus a2u plus a2u plus b2v plus a2h plus b2k plus c2 dv equal now to 0. Then, we have A1U plus B1B du plus A2U plus B2V dV equal to 0. The transform preceding equation is now solvable by homogeneous. Note that upon substituting u plus h and v plus k for x and y respectively, the transformed equation contains no constant term. Now, let us try to solve this one.